Hey everyone, in this video we're going to talk about section 2.7a, which is about the inverse trigonometric functions. So we've always thought about inverse trig as an operation. Today we're going to see that it is a function. So to kind of start us off, first, make sure that you're in radians. You're going to need your calculator today, and you want to be in radian mode, not degree, okay? So let's go ahead. We're going to start with a geometry reminder of how we can solve for missing angles here, okay? So I'm going to have you pause the video, and I want you to solve for each of these angles in these examples. So you're going to solve for angle A and you're going to solve for angle E. So pause your video and then unpause when you're ready to check your answer. So for this first box, we should get that theta is equal to 1.047. Okay, and so I use the cosine ratio to do that. And then for the second box, I got that our angle E was equal to 0.983. Okay, and I use the tangent ratio for that. So for both of these, we did have to use inverse trig to be able to solve for it. So kind of thinking back to what we know so far, we've always seen the input into a trig function as an angle, and we output like a side ratio, right? So input, angle, output, side ratio. So when we're using inverse trig, that is the operation that we are using that's figuring out like, okay, well now our input is the side ratio and the output is an angle, okay? And actually looking at this first box, I know that we got a decimal for our value of A. However, I actually think that we could find a more exact answer. So if we're thinking about this here, cosine, this is equal to 1/2 when we reduce it down. Well, we should be able to figure out an exact value of theta that gives us 1/2 for cosine. And that's actually going to be pi over 3. Okay, so there is an exact answer for this. Okay, so where are we going with this? Well, we're going to figure out what our sine, cosine, and tangent inverse functions look like. Okay, so we're going to start with this graph here, and we're going to start with the sine of sine of x. We know the graph contains these key points, so we're going to fill in this table. So go ahead, fill out the table, graph your points here, and then unpause when you're ready to check. Okay, welcome back. Here we go. Here's our values for your table. Go ahead and double check that. And then here's the graph that I got here. Okay, so the question that we're trying to ask ourselves is, why is the function sine of x not invertible on the given domain? So remember, if we're going to find an inverse for it, we have to have some different properties that exist, okay? So remember, from inverse functions, back from unit 1, what do we know? Well, we know that they must be 1-to-1. Okay, and what does 1-to-1 mean? Well, that means that it has to pass the horizontal line test. Okay, because that means that every single x value and every single y value have to be unique to each other. So just like a function, we can't have more than one y value connected with an x value. Each y value has to be connected to only one x value. So if I'm looking here, well, I can definitely see, even just looking at this x-axis, there's 3 different points where this exists at 0, okay? And so this is not 1-to-1. So I know right now it's not 1-to-1, so technically it's not invertible. We can't find its inverse. However, we can make this function invertible. How do you think we're going to do that? But you can't answer me because you're watching a video. However, we're going to restrict the domain. So what that means, in math class, we always kind of, or I guess in math, it's kind of like, okay, a rule doesn't work for what you're looking at. Okay, well, let's just make up a new rule. Okay, so that's exactly what we're doing here. So we are going to look at our function from just negative pi over 2 to pi over 2. Okay, I'm just going to look at this portion here. And on that next page, we're going to have, we're going to see what this looks like. So remember that when you take an inverse of a function, if you have a function that starts with a point xy, when you find its inverse, the point yx is going to be on your function. So really, we can look at our table values from negative pi over 2 to pi over 2, and we're just going to flip-flop which ones are our x's and which ones are our y's, okay, or what are our inputs, what are our outputs. So what's our input when we get an output of negative pi over 2? Well, it's going to be -1, okay? Our input is going to be negative square root of 2 over 2 to get an output of negative pi over 4. 0 is going to give us 0, and then we'll have positive square root of 2 over 2, and we'll have 1. Okay, so thinking through what these values mean here, well, what did they mean? On our original function here, when we were looking at these x values, these were angles and radians, and then our outputs were our y values on the unit circle. Okay, or those are our side ratios of our triangles. When we're looking at the inverse, well, it's going to be switched now. So now our input values are going to be our y values on the unit circle. Okay, and our output values are going to be our angles and radians. So we're going to let's go ahead and plot these points and see what our inverse sine function looks like. So I see here that my y values, or my y-axis, is labeled with those radians, and then my x-axis is measured with those other values. So at -1, we're at negative pi over 2, so we're down here. At negative square root of 2 over 2, and this is approximately negative 0.707. Okay, so that's going to be, let's see, if this is negative 0.75, it'll be somewhere in here-ish. Close enough. Okay, 0, 0, and then right here, and then here. Okay, so going to connect our dots, our inverse sine function is going to look like this. So they're not straight lines. They do have a little bit curve. We're concave down here. We're concave up here. Okay, so let's think about what the domain and the range is of our function. Okay, and so we're going to call this function sine inverse, or we're also going to refer to it as arc sine. Okay, so these two representations mean the same thing. So our domain here is really going to be what the range of our sine function was. So as a reminder, the domain of sine was negative infinity to infinity, and the range was negative 1 to 1, okay? But because we restricted the domain, it's not negative infinity to infinity. We restricted it to negative pi over 2, pi over 2, okay? So because we're finding our inverse, the domain and range will switch. So now our domain is going to be negative 1 to 1, and the range of our function is going to be what the domain used to be, so negative pi over 2 to pi over 2. Okay. And you might be wondering to yourself, okay, well, why did we pick negative pi over 2 to pi over 2? Like, why didn't we pick anything else? Well, it's because, and I'm going to go back. I know we're scrolling back and forth a lot, but when we're looking over here at our graph, this range incorporates a bunch of nice different values on it. So first, it has all of our ranged values, so I'm going from negative 1 to 1. It also includes 0 in it, so we're going to kind of pick some values that do include 0, do include that origin, and cover and span the entire range, okay? So when we're talking about inverse sine, this is the domain we're looking at, and this is the range that we're looking at. So down here, we're going to see a couple of different evaluate functions, or evaluate statements. So looking here, we have sine inverse of the square root of 3 over 2. Okay, well, remember that square root of 3 over 2 here is a y value on the unit circle. Okay, and I know that we're talking about a y value because I know that sine of x is equal to y over r, which when we're talking unit circle, it's just equal to y, right, because our radius is 1. So I'm trying to think to myself, if I let this be equal to x right now, I'm thinking, okay, well, where is sine of x equal to the square root of 3 over 2? Okay, and so this is where we're going to have to think about our domain and our range to be able to figure out, well, what quadrant are we in? So because we are looking at this being the range of our function, we're not going to think of our entire unit circle. Okay, so I see here that we're going to get some, we're looking from negative pi over 2 to pi over 2. So we are looking for values that satisfy this in either of these two quadrants. So which one's going to do that? Which one has a triangle that has a square root of 3 over 2? Okay, and hopefully by this point you're like screaming at the video like, Miss Dolans, we know what it is. Stop talking. Okay, it's pi over 3. Okay, so that's going to be our value up here. So similarly, if we looked at arcsine of negative 1/2, I'm really kind of thinking about this as, okay, well, what's our input value that gives us an output value, a normal sine of negative 1/2? Well, okay, negative, no, I know that I'm going to be down here somewhere, right? So what's going to be our theta, our value here, that gives us that negative 1/2? Okay, and so you're probably thinking to yourself, well, I know that's my 11 pi over 6, right? Because that's that point down here. Well, not quite, because we have to remember what's our domain or what's our range that we're looking at this in. Well, my range does not include that value, right? 11 pi over 6 is not between negative pi over 2 and pi over 2. So we just have to readjust and redefine this point, so it is. And so this point is also the same thing as negative pi over 6, right? So pi over 2 to pi over 2, negative pi over 2 to pi over 2. So this is equal to negative pi over 6. Okay, hopefully we're kind of seeing this. What we're really going to have to see, though, in these problems, is that when we are evaluating, and I'm going to be more interested in actually asking you statements like this than you knowing what this graph is, we just need to remember what values are going to fall within it, okay? So knowing our domain and then knowing our range will be really important. Okay. One other thing before I go on, and we've talked about this briefly in class, but I want to note that sine inverse of x is not equal to 1 over sine of x. So I know that x to the negative 2 power is equal to 1 over x squared. The same thing does not work for our trig functions. That is another reason why we call this arcsine. It's to just give us another representation that does not make us think of negative exponents in that quotient property. Okay. All right, so we got inverse sine. You know the drill. Flip over our page. We're going to go ahead and do inverse cosine. So I actually want you to go ahead and this entire page here, I want you to pause the video and do this entire page and then unpause and we'll just double check our answers. Looking at our table, we should have output, we should have output values of negative 1, negative square root of 2 over 2, 0, positive square root of 2 over 2, 1, positive square root of 2 over 2, 0, negative square root of 2 over 2, and 1. Okay, so connecting our points, we have our cosine graph. Okay, we should have the same issue of that this is not invertible initially because it is not 1-to-1. So again, looking just even at this x-axis, I have 2 points here. So if we want to make it invertible, we have to restrict our domain. So when we restrict the domain for cosine, again, we're trying to pick strategic values that are going to kind of include 0 as an input value and span the entire range. So we are going to be looking at this portion here. Okay, so we're looking at our domain of 0 to pi because that is going to give us our full range of negative 1 to 1. So that means that when we go to graph our inverse function and flip all of our points, this is what our graph should look like. Okay, so when x is equal to 1, we are at 0. So we actually start over here on the right. When x is equal to square root of 2 over 2, which again is approximately 0.707, we are right here. When x is 0, we are here. When when it was square root of 2 over 2, we're here, and then negative 1, we're here. So actually, this table kind of looks a little bit weird because we are going in increasing order of our range. Really, the function should start from negative 1 going to positive 1. So this table is just kind of backwards. Okay, so the domain of our function is negative 1 to 1, and then the range of our function is 0 to pi. Okay, hopefully we did okay there. So flipping over our page, we're going to evaluate some cosine functions here. So again, whenever we're looking at the inverse, our input is now going to be the x values on our unit circle because we're talking about cosine. Okay, so thinking about what quadrants we are in for our unit circle, we're going to take a look at this range here. Okay, so for instance, unit circle, we're measuring from 0 to pi, so we're going to be looking at quadrants 1 and quadrant 2. Okay, so I'm looking here in my circle and thinking, okay, well, what value of cosine gives me an output value, a y or an x value of square root of 3 over 2. Okay, so I know that I'm going to be in quadrant 1. I'm over here. So what value of theta gives me that version? Okay, and hopefully you're thinking to yourself that's pi over 3, and you are correct. And I'm just going to double check myself just so I know. Nope. Okay, I was off. Hopefully you're thinking pi over 6. Right, because I want square root of 3 over 2. So pi over 6. Okay, same thing for arc cosine. Again, just a different representation of it. We are now looking for what value of cosine gives me that output value of -1/2. So now I'm going to be in quadrant 2 because we're talking about cosine. Okay. So which value of theta gives me this -1/2 x value? That's going to be 2 pi over 3. Okay. So we've talked about sine. We've talked about cosine. The last one we're going to talk about is tangent and inverse tangent. So you know the drill. Go ahead, pause the video. I want you to fill out everything up until the evaluate, and then we'll check our answers before we go on. For tangent, here's the table that we should have gotten. One thing that always kind of helps me, so I always think of tangent. We know that it's opposite over adjacent. We know that it's y over x. I also like to think about it as sine of theta over cosine of theta. That just kind of helps me, because if I can remember the sine and cosine values, I just have to remember which ones to use in my ratio. Okay, so here's our graph. We should be familiar with it. Again, this function is not initially invertible because it is not 1-to-1. So if I'm looking at a horizontal, just that horizontal line, it's going to hit it multiple times. So we do have to restrict the domain again to be able to invert it. Okay, and so we're looking at restricting the domain so we hit all of our range values. We are going to restrict the domain, so we are looking at this portion of our graph. Okay, so the initial domain, once we restrict it, is going to be -pi over 2 to pi over 2. So again, we're not including because we do have those vertical asymptotes, but that will give us our full range of -infinity to infinity. So when we go over to the next page, and I see that we have restricted our domain, which means then we have our range for our inverse tangent. These are the x values that we should get, so undefined, -1, 0, 1, and undefined. With those undefineds on those x values, so as y values, remember those were vertical asymptotes. Well, when they're undefined for our x values, these are going to be horizontal asymptotes. Okay, so here's what our function should look like. So I have a horizontal asymptote at -pi over 2 and pi over 2. And then I have, so which means that I'm undefined for my x values there, meaning that there's never like a specific point that's going to give me that specific y value. Okay, and so it kind of looks like this. So the domain of our function is the range of the original, so -infinity to infinity, and then the range of our function is the restricted domain of the original, which is -pi over 2 to pi over 2. Okay, so that means that when we are talking about inverse tangent, well, if this is our range, again, we have -pi over 2 to pi over 2, we're talking about these two quadrants, so quadrant 1 and quadrant 4. So here we go. So we have tangent inverse of square root of 3. So remember that square root of 3 is the initial output. And so what we are looking for, is what value of x gives us an output for tangent of square root of 3. Okay, so I know since we were positive, we're going to be in quadrant 1. So I'm thinking about this up here. And there are a couple of ways that we can look at this. So, I can actually redraw this. Okay, so I'm in quadrant 1, and I know that this is really the square root of 3 over 1, so I have a square root of 3, and I have a 1 right here. So, again, there's a few different ways to do it. We can kind of talk about in class some different strategies, but one thing that I always like to think of, especially when I'm talking about tangent, is how can I get this in terms of like square root of 3 over 2s and 1/2s, because that's really what we're normally used to seeing, because that's what's making up our unit circle. So I'm actually going to scale this down. I'm going to multiply both of these by 1/2. So multiply by 1/2, multiply by 1/2. And I can do that because I'm just doing both of them, so I'm just making my triangle smaller. So now I have the square root of 3 over 2 over 1/2. So on my unit circle, I'm trying to think about what point or what value of theta gives me this point where this is y over x, my x value is 1/2, and my y value is the square root of 3 over 2. Okay, hopefully you're thinking to yourself, this is pi over 3. And you'd be correct if you said that. Okay, so again, there's a couple different ways to do it. You could have also looked at this and saw that this would have been a 30, 60, 90 type of triangle, which would have meant that this is 60, and then you could have converted 60 to radians. Either way is fine. Okay, last one is arctangent of -1. So again, if we're thinking unit circle, we're in either of these two quadrants. We are looking probably at quadrant number 4 because we are negative. So I'm thinking, okay, what value of theta, what angle is going to give me a tangent value of -1? Well, again, if I'm thinking about my x values and my y values, okay, and I'm thinking about unit circle things, I know that my tangent, if it's y over x and it reduces to -1, they're going to be the same, right? And so the only same coordinate pair of x and y is going to be square root of 2 over 2. So I see I'm in positive x's, so I'll have positive square root of 2 over 2, and then a negative y, so negative square root of 2 over 2. And thinking about our value of theta that does this, well, again, this might normally be 7 pi over 8. 8, whoa, where did I get that? Why won't it erase? It froze. Uh-oh. I wonder if it's still recording. Okay, well, I don't know what happened there. 7 pi over 4, but that's not in our range that we are dealing with. So we're going to reconvert this, and this is going to be negative pi over 4. Right, because we're going from negative pi over 2, or negative pi over 2, and then to pi over 2. Okay, so that's all the notes for now. In this next section, we're going to talk a little bit more about the inverse trigonometric functions and how to do compositions with them. Right now, we need to focus in on, we need to focus in on how to do these types of questions, okay? So I know that we just learned about these graphs. Really, the graphs are kind of just visual representations. What we're going to be focusing more on in class is these evaluate statements, okay? So that's all for this video. I will see you all later.